to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to yet another video on my channel coming for your Term 3 Math exam review. So in today's session we are going to be covering Learning Objective 7 from Part 1 where we will find the maximum and minimum values of a function at a point. So let's get started with today's video. If you see Learning Objective 7 that's come from exam coverage, you have to find the maximum and minimum values of a function at a point. These are questions 8 to 13 based on page 9 of your math book. This is from the lesson Linear Inequalities. So here if you see for each part of the question, you first need to graph each of the system of inequalities. Then you need to find the feasible region and name the coordinates of the vertices or endpoints of that feasible region. Preferably shade the feasible region and then calculate the objective function which is given for each question in terms of f of x, y, and for it find the maximum and minimum values for the given function. So a lot of things to be done. It's going to be a long question. I will show you first how to solve question 8. Let's do it on the next slide. So this learning objective number 7 where you find the maximum and minimum values of the function at a point. This will come in your ministry exam for the multiple choice question. That means you'll have to do this question quickly and there will be options. That means they are going to give you for each part, say for question 8, maybe 4 options. They will show you the feasible region, they will give you the maximum and minimum values and you have to just select the correct option. So instead of solving the whole question, step by step, we will just directly go to graphing calculator called Desmos, and I'm going to be using Desmos for getting the feasible region and the endpoints of the feasible region for each of these questions 8 to 30. So let me take you to Desmos. I will also put the link of the Desmos graphing calculator in the description box, so make sure you click there and try this yourself for getting the graphs quickly and saving time for your exam. So let's make the graphs of each of the system of inequalities for question 8 first. So the first one that I'm taking here is 1. I'll go to this keypad, less than equal to, then I go to y. So this is one such system of inequalities. So if you see, this point is 0, 1 and this is the shaded region. Now in the same, I'm taking the other one also, which is less than equal to 4. So you know that the common region between these two is in between 1 and 4. Okay. Now we move on to the next system. So the next which is given, I'm typing as given in the question, greater than equal to minus 32. So this is going to be this shaded region. And remember, we have to take the common shaded region. So we will draw the last inequality as well. So this is the last one. So now that we have everything, let's go to the graph and take the common points. That means the endpoints of the feasible region. As you know, the feasible region is the common region. So if you look carefully, this common shaded region in the form of like a trapezoid is the shaded region. So what are the endpoints? This is one endpoint, 2, 1. I want you to note down the endpoints because we are going to calculate in the next slide when we go back to the presentation at these endpoints the value of the objective function, because that is what we need to maximize and minimize. So 2, 1, this is 1 point. The next point, let's go to this endpoint. It is 6, 1. The next endpoint is this, which is 8, 4. And the last endpoint is this, which is minus 4, 4. So at these 4 endpoints, I'm again just marking it here, you all can see. So at these 4 endpoints, we have to take the value of the objective function, and then from the value of the objective function after substitution, we get the maximum and minimum values. So let's go back to the presentation and calculate our maximum and minimum. So for question number 8 that you see here, we have seen from Desmos the feasible region. So this is one point, another point, another point, another point. So these are the corner points of the feasible region. Now comes calculating the maximum and minimum value. So for that, we draw the table of values. And how do we do that? We first write the objective function. So for this question, the objective function was defined by f of xy equal to minus 6x plus 3y. So now in the table, what we are going to do, let's see. In this table, we are going to calculate minus 6x plus 3y. This value, what it comes out to be at each of these 4 points. So the first point, 1, 2, 3. Okay, let's make a rough table. So the first point that I have here is, I'm changing color, is minus 4 comma 4. So when I put that, it becomes minus 6 times. In place of x, I put minus 4. In place of y, I put 4. So this is method of substitution that I'm using. So when you simplify, use your calculator, this value comes out to be minus 36. Next point I'm taking is 2 comma 1. At 2 comma 1, this value comes out to be minus 6 times 2 plus 3 times 1, substitution. So simplify and it comes out to be minus 9. Next point 6 comma 1. And last point 8 comma 4. So at 6 comma 1, this value is minus 6 times 6 plus 3 times 1, and on simplification this gives you minus 33. Finally, last point, minus 6 times 8 plus 3 times 4. Simplify and this value comes out to be minus 36. Just to make one correction, when you put minus 4 and 4, this value will come out to be plus 36. So now it's quite easy to identify the maximum and minimum. So here the maximum value is 36. So we can say that the maximum value of the given function for this feasible region is going to be 36, and the minimum value, as you see, is going to be minus 36. Okay, and if in addition, though this is not mentioned in the question, they also ask you what is the coordinate of the vertices where this happens, then the maximum is achieved at the point x equal to minus 4, y equal to 4, and minimum is achieved at the point x equal to 8, y equal to 4. So this is some additional information, and out of the options that will come in your exam, please select the correct option in this manner using objective function. Let's now use Desmos graphing calculator to draw the graphs of the linear inequalities that you see in question number 9. So here the inequalities which are given, let's first write their inequality. So this is 2 greater than equal to x greater than equal to minus 3. And I want you to notice how the graph here on the right on Desmos is changing. Okay, so no need to do these graphs mathematically or algebraically. You can directly use Desmos graphing calculator, because in your exam this will come in multiple choice questions, so the graph we expect will already be given to you. So just check which one will give you the maximum and minimum values, and that will be all in the question. So this is how we draw the graphs of the inequalities which are given in question number 9. So here we have drawn all the inequalities. So let's now go to the graph and look at the feasible region. So for this question number 9, if we look at the feasible region, it is going to be having the following endpoints. This is 1 point. We will just zoom out a little bit from the graph so that you can see the shaded region nicely. So if you see, the common area has the coordinate 1, this is the feasible region. 2, this is the next one. Then you have this point, so I will make it like this, and finally this point. So these are the 4 coordinates of the feasible region. So we are going to calculate for question 9 now the objective function and its value at these extreme points. So when you get such a question in your exam, just look at the options and you can easily from the options put these values of the endpoints, because the graph will be given to you. From the graph which is given like this in your exam, calculate and identify correctly the endpoints like I did for this question, and then make the table of values as we will see in the presentation when we go back. And at these extreme points, the 4 points that you see here, calculate the value of the objective function f of xy which is given. From there, just take the maximum and minimum, and that will be all in this question. So let's go back and do it. So let's complete our answer for question number 9. So here if you see the objective function f of xy as given in the question is minus 4x minus 9y. So as we did in the last question, we are going to make the table of values, and at each point of the feasible region that you see here, we will calculate the value of the function and see what it comes. So f of xy equal to minus 4x minus 9y. We will now make the table of values and calculate one by one. So the first point that I'm taking here is 2, 9, this point. So when you take x as 2, y as 9, and you put it in this equation, it gives minus 4 times 2 minus 9 times 9. So simplify, and this comes out to be minus 89. Next point that I'm taking is 2, minus 10, which is this point. So when you substitute and try to find the value of the function, this comes out to be this value. So on simplification, this comes out to be 82. Next point, minus 3, 0, this point. So again, do the same thing. Calculate the value of the function at this point. This becomes 0, so this is just 12. Last point, which is decimal, is minus 3, 6.5. Put that in the equation, and what you get is minus 4 times minus 3 minus 9 times 6.5. So again, this comes out to be minus 46.5. Now we need to choose the maximum and the minimum values. So the maximum value of the given function for this feasible region, as you can all see very clearly, is 82. So this is the maximum value, and it occurs at the point x equal to 2, y equal to minus 10. And the minimum value here is definitely going to be minus 89, and this is at the point x equal to 2, y equal to 9. So this is how we complete these kind of questions, where we find the maximum and minimum values of the objective function at a point. Also, we graph the inequalities and look at the feasible region. So this is how you solve questions 8 to 13. I hope you have understood from the video how we find the vertices of the feasible region, how we shade it, and then how we use the objective function and find the maximum and minimum values for the region. That brings us to the end of today's video. I hope you found the video useful and you learned how to graph each of the system of inequalities and find the maximum and minimum values of the function at the feasible region. Until then, this is Ms. Ruchika signing off from today's video. See you in my next video. Bye bye.